Hello everyone, this time we're going to talk a little bit about pressure. Pressure is defined as the force exerted per unit area. This is our equation for pressure. Please make sure you put that on your formula sheet. That's an important one. Lots of uses for pressure, everything from weather forecasting, different kinds of hydraulics and air pressures inside your car, pressure washers, of course, trying to clean things around the house, many different medical applications having to do with respiratory gases and things like that. Now, capital P in our equation is pressure, measured in a unit called a Pascal. Pascal is not something that you may be comfortable with because it's not in everyday language. We'll talk a lot about Pascals. F is force in our old friend Newton's, and area is square meters. So to put that in mind, a square meter is 1 meter tall, 1 meter wide and 1 meter long. So it is about 1 yard by 1 yard. It's a lot of space. I love the concept of pressure because before we get into the math, you know an awful lot about pressure before we even get into that. Let's talk about this situation. If you want to reduce the pressure on something, one of the ways you can do it is increase surface area. So here's my equation. If I make surface area, the bottom part of this equation, really big, what's going to happen is pressure becomes really small. Some examples of that are snowshoes. Well, the idea of snowshoes is you're going to walk on top of the snow instead of sinking every single time you take a step. It makes it much easier to walk on top of the snow. And you do that by taking your weight and spreading it over a much larger surface area. Same sort of idea for cross-country skiing. Instead of your weight being over your little feet, it is now over these much larger surface area of your skis. Look at this cute little snowshoe hare. This little snowshoe hare has got big feet, but he evolved in a situation to be in a winter environment. Big feet allows him to move very quickly on top of fluffy snow so he can outrun predators. If you've lived in the North Country, and you might know the safety mantra of what you're supposed to do if you happen to get out on thin ice. If you're out walking around on ice and you hear it crack underneath you, what are you supposed to do? Yeah, you're supposed to lay down, because once you've laid down, it's hard to draw somebody laying down. I don't know. If you lay down and then kind of scooch yourself onto thicker ice, because of the fact that you take your force, your weight, put it over a large area, and that's going to make that pressure small. I found this and it amused me, so I had to include it from the Department of Natural Resources. Minimum ice thicknesses for everything from ice fishing to trucks to Godzilla to an AT-AT, which is an all-terrain armored transport, I think. You who are bigger nerds than I will know that. Let's take this whole situation and reverse it. So if I take the same amount of force and put it over a tiny area, I can get big pressures. Well, that's the whole concept behind a pressure washer. Pressure washer, you're just taking water out of a hose, but because it's coming through this tiny little nozzle, it has such high pressure, you can use it to clean gunk off of decks and siding and houses and things like that. Surgical steel blades, they are designed to be very thin. And because they're very thin, very small surface area, small amount of force gives the surgeon big amounts of pressure. People who are hockey players, ice skaters, they are going to have skates sharpened constantly, and they are going to be sharpened to be wicked sharp, because they want really small surface areas to give them a lot of pressure. And when you skate, the pressure down is going to melt the ice so that they are actually skating on a thin layer of water. And that water refreezes as soon as they're passed, but there's almost nothing as slippery as water on ice. If you are going to use a punch, a metal punch to push a hole through metal or dent a piece of metal, a lot of force, tiny little area, and that's how that works. Other examples of pressure. Now, if you took a small child and had them sit on one nail, you would be arrested for child abuse, and rightly so. But they have big beds of nails in science museums that are fun and a novelty because you take your weight and put it over large quantities of nails. It's not comfortable, but it's survivable and it's not going to do you any harm. Same thing with the balloon. Balloon over one nail, that's going to be dangerous, but a balloon over many and survivable. Golf spikes. Golf spikes are fabulous when you're out golfing because of the fact they're going to give you nice grip on the grass, but they don't want those spikes in the clubhouse because you're going to damage the floor. All your weight, tiny little surface area, and you're going to punch holes all over the floor. These are caps for heels. Now, I first encountered these as a wedding guest. They had some, this was an outdoor wedding, and they had them for all the ladies who was wearing spike heels. And the idea was these ladies were going to sink into the grass with their skinny little heels. And if they gave them heel caps, they took their weight and spread it over a much bigger surface area so that the women in very tall heels wouldn't stuck into the grass like yard darts, which I thought was kind of nice. Now, pressure units are weird and crazy units. There's a lot of them. We're going to do some practice problems just converting because they're strange units. The official metric unit of pressure is called the Pascal, abbreviated capital P, lowercase a, and 1 Pascal is 1 Newton per meter squared. From the equation, force divided by area, force in newtons, area in square meters. So this is a derived unit come up with from the equation. But other pressure units you're going to see include atmospheres, millimeters of mercury, inches of mercury, pounds per square inch, torrs, and of course pascals. Now all of these happen to be equal to each other. Now why are there so many of them? Well, there's so many of them because of how air pressure is measured. Back in the 1600s, there was an Italian gentleman named Evangelista Torricelli, and Torricelli communicated with Galileo. Matter of fact, towards the end of his life, Torricelli was a house guest of Galileo for many months. And Torricelli was a mathematics professor, and he really was interested in air pressure. He invented something called the open dish barometer, and here's how it works. He took a long tube of glass, and he filled it from top to bottom with the element mercury. Now, today we don't play with mercury as much as people did in the past because we know that it can be chemically very, very dangerous. But 400 years ago, it was not known about the dangers, so people did that. They filled it full of mercury with his thumb over the end, tipped it upside down, put it into a dish of mercury, supported the column with some supports, and then allowed the mercury in the tube to fall down and seek its own level. When it seeked its own level, what happened, or sought its own level, it created a vacuum at the top. By creating a vacuum at the top of the tube, that produced no resistance for this mercury column to rise up or fall down. So what happened was this. Because this is an open dish, atmospheric pressure would push down on the dish of mercury. When we were experiencing high atmospheric pressure, there would be high pressure on the mercury fluid, and the column of mercury would rise. When there was a low atmospheric pressure, there would be less pressure on the entire dish, and the column of mercury would fall. And it's this height of mercury that is quoted as atmospheric pressure today. Millimeters of mercury, centimeters of mercury, and 760 millimeters of mercury, which is at sea level called standard pressure, is also called 1 torr, which means 1 Torricelli, named for this fellow who invented the open dish barometer. 29.92 inches is the same height of column of mercury, but in the English system. So we have the metric and the English version, and then we have the version named for the fellow, and that gives us 3 unique sets of units that you are going to see. Now, standard atmospheric pressure at sea level a torricelli, millimeters of mercury, inches of mercury, centimeters of mercury. And it all goes down to the design of the open dish barometer, even though this is not the kind of instrument that is used very much anymore because of the hazard of mercury, but the units have stuck. Now, what produces the atmospheric pressure? Atmospheric pressure is produced due to the weight of the air pushing down on the earth. So another common unit of pressure is called pounds per square inch. At sea level, standard atmospheric pressure is 14.7 pounds per square inch, also abbreviated PSI for pounds per square inch. So what this means is if you take 1 square inch of space, about the size of your thumb, about the size of a postage stamp, and you take a skinny little column of air to the top of the atmosphere, about 55,000 feet up, and you weigh all the air in that entire column of air is going to weigh about 14.7 pounds. That's where they get this concept of atmospheric pressure. If instead of a square inch, you have a square meter, meter times a meter, and you go to the top of the atmosphere, you are going to get 1 newton's worth of weight. That ends up being the unit, the Pascal. Another kind of barometer that's much more common, if you have a barometer in your home, I have one in my home, it's probably an aneroid barometer. Aneroid is this little flexible can that's actually located inside the barometer. It's a little corrugated metal can, and inside of it has a partial vacuum. And how it works is this. When there is a low atmospheric pressure, the can expands a little bit, gets a little bit fatter, and it's attached via some mechanisms to a pointer so that it is going to indicate a low pressure. When there is a high atmospheric pressure outside, the can is going to collapse slightly. That is going to move the position of this lever, and it's going to indicate that the pointer is going to go whoop, over there somewhere. So this is a very safe kind of barometer and relatively inexpensive. If you want one in your home, you can buy them at most superstores for under 20 bucks, and they're pretty nifty. We're going to do a simple pressure calculation right now. Pressure is force divided by area. And I want to know, if you take your hand and you're just kind of raising your hand, I want to know, when your hand is kind of sitting like that, what is the weight of air from your hand up to the top of the atmosphere that your hand is supporting. So we're going to have to do some estimating of the area of your hand. So I'm going to use my hand. Why? Because my hand's handy. And I'm going to pretend it's a rectangle. It's not, but it's pretty close. So I'm going to say my hand is 4 inches wide and 7 inches long. So 4 inches by 7 inches, I've got 28 square inches is the area of my hand. I want to know the force of the air I'm pushing up. So force is going to be pressure times area. If I happen to be dealing with standard atmospheric pressure, 14.7 pounds per square inch times 28 inches square. Inches squared are going to cancel. I'm going to pick up my calculator, 14.7 times 28, and I've got 412 pounds. Holy moly, Batman, that is a lot of weight. If you can use both hands, you are powerlifting 824 pounds. Craziness, huh? All right, a lot more to talk about pressure, and we'll do it next time. See you later.